All right, for part B, let's see what we have. We have 5 plus x squared to the power of 3 halves. Okay, that looks like it's the sum of the squares, right? It's the sum of the squares. You have, let me just write down 5 plus x squared to the power of 3 halves, right? But I just need the sum of the squares part. So in other words, I need only this part to figure out to pick the right substitution. This is radical 5 squared plus x squared. Okay? And I got to rely on to the same trig substitution as in part A. This is the sum of the squares, even though I don't have the square root directly here, but it's the sum of the squares. So I'm going to use u equals a tan theta. So it's number squared plus u squared. And here that number is radical 5. So I'm going to go with x equals radical 5 tan theta. Okay? So that 5 plus x squared is radical 5 squared, which is 5, plus 5 tan squared theta. And that is me pulling out 5. And 1 plus tan squared is secant squared theta. There we go. All right, so now I have a perfect square. And when we have x equals radical 5 tan, so what is the dx corresponding to that? Well, dx, let me just write with the same color. dx is radical 5 secant squared theta d theta. That's the secant squared is a derivative of tan. Okay. All right. I think we have all the ingredients except the triangle. Okay. And here for the triangle, all I need is to write down what tangent theta is. Tangent theta is x over radical 5. Okay. I'm going to go ahead and then draw the right triangle. Okay, I'm going to place theta right here, and tan of theta is x over radical 5. Okay, so tan is opposite divided by adjacent, so it's x over radical 5, and the hypotenuse is the sum of the squares of these guys. So radical 5 squared, which is 5, and plus x squared. Okay, so I think I have all the ingredients. I have all the ingredients to start working on converting this integral to the theta version of that. Okay, so let's see. I have 1 over 5 plus x squared, and 5 plus x squared is already 5 secant squared to the power of 3 halves times. I have dx, and that is radical 5 secant squared theta d theta. Okay? All right, let's just simplify this. 1 over 5 to the power of 3 halves. And secant squared to the power of 3 halves is secant cubed, because we multiply the powers, right? Power of the power, right? So it's secant cubed theta. And then radical 5. Radical 5 is 5 to the power of 1 half, by the way. And then secant squared theta d theta. Okay, there's a lot of cancellations here. Well, first of all, secant squared theta cancels this 3 here. I have only the first power. That makes it only a secant theta. Okay. 5 to the 1 half cancels this. And you're left with only 5. Because 5 to the 3 halves is 5 to the 1 times 5 to the 1 half. So we're only left with 5 to the 1. And in turn, we have, let's see, the only thing I'm left with is 1 over secant theta d theta. Okay? And good news is that secant theta is 1 over cosine theta. So let's flip over 1 over cosine theta. And this is cosine theta d theta. Okay? And cosine theta d theta is integrated as sine theta plus c. Okay? Okay, I think I am, let me see if I forgot the 5 here, I'm sorry. I was checking like, I think I forgot something, but I didn't see what exactly. Here we go, 5 sine theta, okay? So now let me erase this part completely because I only need to retrieve data from the triangle, okay? That's all I need, and that's already in different color anyway, okay? There we go. I'm gonna go ahead and continue writing 5 sine theta. Sine theta is opposite divided by hypotenuse, okay? X over, let's see, x over, is it 1/5? I'm sorry, it's just, this is 1/5, right? Because 5 is in the bottom. 1/5. And then 1/5, sine is opposite divided by hypotenuse. There we go. All right, sorry about the 2 typos because of that constant down there. Okay, I think I should add also plus c. I think that is the end of it. Okay, so in this example as well, we used tan theta type transformation because it's the sum of the squares in the bottom to have this integral integrated. All right, so for part C, please move on to the next video. I'll see you there.